This tutorial will be discussing amides. Amides are derivatives of carboxylic acids. If you look here, this is a carboxylic acid. If we take away the OH part and put a nitrogen instead, that's what an amide is. Amides are produced by reacting carboxylic acids with ammonia or a primary or secondary amine with the addition of heat. So the OH from the carboxylic acid and the hydrogen for ammonia come together to form the CN bond. Keep in mind it says primary or secondary. If it was tertiary, it wouldn't work because there'd be no hydrogen here to give up. So let's predict the product of the following amidation reaction. This OH group goes away, and so does one of these hydrogens. So that gives us a benzene group. With a carbonyl group. And instead of having that oxygen there, we're going to have a nitrogen there instead. And that's attached to a CH3 and another hydrogen. In both the common and IUPAC names, amides are named by dropping the OIC acid for the IUPAC or the IC acid from the carboxylic acid name and adding the suffix amide. Alkyl groups attached to nitrogen of the amide are named with the prefix N. So if there's two of them, you'll say NN. So let's take a look at this. Let's look at what the carboxylic acid is. We have 1, 2, 3, 4. So instead of butanoic, butane amide. Now let's look at that nitrogen. It has a methyl group on it. So N-methyl butanamide. How about this one? This one doesn't have anything besides hydrogens coming off that nitrogen. So it'd be ethanamide. This one has an ethyl group coming off that nitrogen. So N-ethyl propanamide. You may remember when I was talking about how to name esters, where you put the line between the O's. Well, now if we still put the line between the O and the N, the double line still tells us that we're going to name it second. Acid hydrolysis produces carboxylic acids and ammonium salts. So that actually breaks up that carbon-nitrogen bond. That HOH then gets attached to the different portions. So the OH portion reforms that carboxylic acid. That H is how you get the ammonium, salt. And then that chlorine there. Base hydrolysis with heat to produce the salt of a carboxylic acid and an amine or ammonia. Once again, just like with saponification of the esters, here's that ONA. So here's the carbon attaches to that oxygen and the metal to produce that salt. That hydrogen then gets attached to the nitrogen. Draw the condensed structural formulas for the products from hydrolysis of N-methyl pentaamide. So we know we have an amide here. And on that nitrogen we have a methyl group. And we have pent, which means 5. So 1, 2, 3, 4, 5. Let's draw in those hydrogens real fast. We're reacting this with NaOH. This is the base hydrolysis. So we're going to break this up. I'm going to do this in a different color just so you can see. CH3, CH2, CH2, CH2. That's 4. Here's our 5th for pent with our oxygen. And this portion here, the O and A, is going to produce our salt. Then in addition to that, let's get a different color. We have this nitrogen group, NCH3, with another hydrogen coming off of it. That's not written in there. And now we have another hydrogen. So there's our base hydrolysis. We had the carbon and the nitrogen bond split up. The oxygen and sodium went with the double bonded oxygen, and then the hydrogen went with the other side. Please note as you're looking at this that the pictures aren't exactly going with it. This is propanamide and this says methylpentaamide. Draw the structures of the following pentaamide. So CH3, CH2, CH2, CH2. There's 4 carbons there. Pent is 5, so there's our 5th. Amide means I have a double bonded oxygen bonded to a nitrogen. There's nothing coming off the nitrogen, so it's just NH2. Draw the structures of the following. N-ethylbenzamide. So let's do the benz part first. Ordinarily, it would be like a benzoic acid, and there'd be an OH coming off of here. But it's an amide instead, so it has a nitrogen there instead. And then we have 2 carbons for the ethyl group, and another hydrogen. And that's your overview of amides.